Welcome back everyone. Today we'll be learning about hydrostatic law and Pascal's law under fluid pressure and measurement topic. Okay. The summary is that hydrostatic law states that pressure increases linearly with depth. You might have experienced if you went for swimming in the swimming pool, the more deep you dive, the higher the pressure you feel in your ear. Okay. And then we have Pascal's law. Pressure at any given point in a static fluid is equal in all directions. Okay, what are these states? Like let's say you have a beaker at any given point, the pressure acted upon is same in all directions. For example, let's say you have a balloon filled with air. You try to push it into the water, then it gets shrunken uniformly. Why? Because the pressure uh, is equal on that balloon in all directions. That's why it gets shrunken uniformly. Okay. Now we will try to derive what are uh, now we will try to derive hydrostatic law. Its equation. Okay. Let's say we have a beaker, and that in that we have a small cylinder. In that, water forces are acting upon. On this, there is a force on top of the cylinder. Then there is a force on bottom of the cylinder. Then its own weight. All these three forces are acting upon it in a y-axis. Okay. Uh, what is weight? Weight is equal to mass into gravity. How do you calculate mass? You multiply density with volume. We have density, we have constant area, but the height we have considered as very small. So let's say it's dh, delta h, very small height we have taken into gravity. If pressure on top of cylinder is pa, then bottom will be something either plus or minus of p. So we consider that as delta p, p plus delta p. So the top force is pressure into area. At the bottom, the force is pressure plus delta p into area. Okay, and since the cylinder is in equilibrium, so the vertical forces acting upon total vertical forces acting upon it is equal to zero. So how we write it down? In this direction we have this force p plus delta p into a, and other two direction are in opposite. Other two forces are in opposite direction, so we minus it and minus weight equal to 0. Now this pa and pa gets cancelled. We have delta p into a minus w, as we have written here, rho a delta h into g equal to 0. Now a gets cancelled. Now dp is equal to rho a dh. If we take dp by dh, if I take dh this side, then dp by dh equal to rho into, sorry, a mistake, rho into g. This is hydrostatic law. If you integrate this, then you get then you get famous equation, which is pressure is equal to rho g h. Okay. Now we'll talk about Pascal's law. What does it states? Pressure at any given point in static fluid is equal in all directions. Okay. Now we will prove it using derivation. Assume you have a small prism inside the water, inside a beaker. Okay. Uh, the this width of this prism is considered as one unity, and the height in y-axis is considered as dy, and in x-axis it is considered as dx, and the diagonal considered as ds. Why we considered as dx dy ds? Because this is very small prism. To prove this, we assume this is very small. Okay, now we'll try to prove the theory. First, as we know that this is also at the equilibrium position, which means uh, the block is not uh, this block is not moving. If it's not moving, then all the forces acting upon in the one in single direction is equal to zero. So in x-axis, the summation of all forces are equal to zero. What all are there in x-axis? One is obviously F2, and then we have F3, which is in diagonal, which is perpendicular to this diagonal plane. Okay, so if you uh, if you if you use vector, then in x-axis what it will become? It will become F3 into sine theta. So F2 minus F3 sine theta is equal to 0. What is F2? F2 is pressure into area. What is pressure in this direction? That is Px. What is pressure in this direction? That is Pz. So Px into area, what is area? This is dy and this is 1. So this is Px into dy into 1 equal to, here minus F3 sin theta I have taken this side. So what is F3 here? F3 is Pz into area. What is area? ds into 1. Okay. So Pz into ds into 1 into sin theta as it is. As we know, as per trigonometry, dy, which is opposite by diagonal, is sin theta. So we know that dy by ds is equal to sin theta. So what is dy? Dy equal to ds into sin theta. Now we put this equation 2 in this equation 1. Then what it becomes? Px into dy, as it is having taken. ds into sin theta is equal to what? Dy. So pz into dy. Now dy gets cancelled. What is remaining? Ps equal to pz. Okay. Now we'll prove it in similar way for y direction. Again, summation of all forces in y direction is equal to 0. What are there in y direction? One is F1 obviously, and then there is F3. Uh, F3 is in a certain angle, but if you project it in y direction, then it becomes F3 cos theta. So F1 is equal to F3 cos theta. What is force? Force is pressure into area. So F1 is Py into this area. What is this area? Dx into 1. So Py into dx into 1 equal to F3. What is F3? This is Pz, pressure into area. What is the pressure? Pz into what's the area? ds into 1. So Pz into ds into 1 cos theta as it is. Again, the same manner that we have found out this, as per trigonometry, if you divide dx, what is dx? Base by diagonal. Sorry, if you divide base by diagonal, then you get cos theta. So as per trigonometry, dx by ds equal to cos theta. Okay. Now we put this equation in this equation. Then what happens? Py dx is what? ds into cos theta. ds. So I have put ds into cos theta. Then at the place of pz, I have put pz as it is. ds cos theta, ds cos theta I have put as it is. Now this both gets cancelled. Then what is remaining? Py is equal to pz. We have found that py equal to pz. Here we have seen px equal to pz. So if a equal to b equal to c, then a equal to b equal to c. So px equal to py equal to pz, which proves that pressure at any given point in a static fluid is equal